get started. Hello, everyone. Welcome to this session. So, if you're in DevOps, with a quick show of hands, let me know if your management has ever called you into the office and told you that you're not spending enough money and you should go ahead and spend more money. Who has that problem? Who has that sort of problem where you need to spend more money? It looks like instead of being asked to spend more money, you typically would be asked to spend less money, right? So nobody says, cut down your performance. Nobody says reduce the number of clients or customers that you can support. Instead, what you're told is you need to find a way of saving on expenses, right? And that's because investors are always talking about how you can save money. And so that's what we're going to be talking about. Now, it turns out, if you're in DevOps, you know that everything runs on a VM somewhere. It runs on a computer, right? It could be virtual, it could be physical, but it runs on a computer. If you're a standard software dev, you probably don't realize that things run on computers. So let's take a look at a typical scenario where we need to set up a GKE cluster. So we have this workload, and we just need to make sure that it's responsive. So if we don't have a lot of demand, we scale down on consumption. If we have a lot of demand, we scale up on consumption, right? Standard problem, standard requirement. So to do that on GCP, we need to first of all choose our region and our zone. And this is important. We need to choose a region and a zone because we need to worry about minimal latency, right? Now, once we choose a region and a zone, we're able to go out and create a GKE cluster. Now, on the screen, we have the CLI command for setting up a cluster. Now, we could leave out the machine type, but there's a reason why we're specifying the machine type. Is because we're going to be talking about machine types. So we can leave out the machine type, and it will create a cluster with a default machine type. Now, in this case, we're using a certain machine type, the E2 class, and we're using an E2 medium. And what happens when we create a cluster like this, notice that a lot of the definitions are missing. But what happens is we end up with a cluster with 3 nodes. So that's the default. So if you don't specify the number of nodes that you want, you end up with 3 nodes. Now, the E2 medium has its own spec. But what we can see here, after the cluster has been deployed, is that we have 3 nodes, we have 6 virtual CPUs, and we have 12 gig of RAM, okay? So that's reasonable for starting out. That's reasonable for a small workload. And we have a screen that shows us the cluster basics. We can go further and see the 3 nodes that we have in the node definition. We see how much CPU is available for allocation, how much memory is available for allocation, and even how much storage we have available and requested, okay? Now, if you go to your compute engine page, you can see the 3 nodes that were created and all the details that are available for them. Okay, so let's talk about the E2 medium machine type. What is it, and why are we using it? So if you try to create a VM instance and you pick the E2 medium machine type, you see that it has 1 to 2 virtual CPUs, but it has a shared core. And that's important to note. You also see that it has 4 gigs of memory, okay? So that's on the left side. On the right side, you see how much it costs to run this VM for a month. And we see that it costs roughly $28 for 4 gigabytes of memory and 1 to 2 virtual CPUs with a shared core. Okay. Now, this amount needs to be multiplied by 3 for you to arrive at how much it's going to cost you to run this cluster for a month. Okay? Now, again on the screen, we've extracted the details. 2 virtual CPUs, 1 shared core, 4 gigabytes of RAM, and a 10 gigabyte disk, okay, 28 USD a month. All right, so it turns out that sometimes when we pick a VM, we don't really think about the architecture, right? Sometimes you're just thinking, yeah, a VM is a VM, let's just pick it and move forward, right? It's kind of like how when you first started out buying computers, you want a laptop, you buy a laptop. You know, sometimes you just look at how much does it cost. Okay, it fits my budget, I'm going to pick up this laptop. But how often do you think, oh, it's an Intel or it's an AMD? I have this piece of software that I need to run on it, and will it run on it, and will it run on it efficiently, right? And so that's what we're doing when we take a look at this T2A. We're then saying, we're not just going to pick a VM, because there are all sorts of VMs. So if you go and try to create a VM, you see you have all these VM types. There's a C4, there's an N4, there's a C3, there's an E2. What are all these? But today we're talking about this T2A, right? And T2A says it's for scaling out workloads. And then there are some interesting specs. So we can see the T2A lets you choose between 1 and 48 virtual CPUs. You can choose between 4 and 192 gigs of RAM. But then there's something interesting on the platform side, right? So typically, if you look at the C4 is an Intel Emerald. The N4 is an Intel. And so you have various platforms, but we're used to Intel and AMD. But the T2A is based on what's called an Ampere Ultra. So what's this Ampere Ultra, and why are we picking it? Okay, now we'll pick up the T2A, and then we'll pick up a T2A standard 1, which is really like the smallest that we can pick. We'll take this T2A standard 1, which is really the smallest. Now we see that this has 1 virtual CPU, and we see that it has 4 gigs of RAM. But if we come down to the core ratio, we see that we have 1 virtual CPU per core. So this is a dedicated core. This is not a shared core. And then if we look to the right, we see that this costs 30 USD. So this is $2 more than the medium that we looked at. But the point here is we're not using a shared core, okay? And so if we choose to use the T2A standard 1, it's going to cost us $2 more, or $6 more if we look at the 3-node setup, okay? So here we have 1 virtual CPU, but it's a dedicated core, 4 gigs of RAM, 10 gigabyte disk, okay? Now, the E2 medium that we used was a shared core machine. It was $2 cheaper, but it's not an apples to apples comparison. So let's do an apples to apples comparison. And in order to compare apples to apples, we'll have 3 different platforms: the E2 standard 2, the N2 standard 2, and then the T2A standard 2. The reason being, we will have the same amount of memory, which is 8 gigs. But when we take that 8 gig baseline, we find that the T2 standard 2 has 2 CPU cores, while the others have only 1 CPU core. And it has 2 virtual CPUs, while the others have 1. So we have twice the amount of CPU, but the same amount of memory. When we look at the monthly cost, we see that the E2 standard 2 costs about 55 USD. The N2 standard 2 costs about 63.5, and the T2A standard 2 costs 60 USD. So it lies somewhere in between those two. But remember, you have twice the number of CPUs, right? So you're kind of getting a good deal here. Now, you can then go ahead and use them when you spin up a cluster. But because it's a VM, you can use it in other places beyond just a cluster. You can use it as a standard VM. You can deploy your databases on it. You can deploy other workloads on it, right? So here we have on the screen a definition for setting up a cluster using a T2A. Okay, and when you're done working with your cluster, you can also delete it, right? Now, the T2A isn't available everywhere, so that's why I'm using it in Europe West 4. But you can always look. It's getting available in more locations, so you can take a look and find locations with the least amount of latency. Okay, so the T2A is an ARM-based CPU. So it's not an Intel, it's not an AMD, it's ARM-based. It's based off of the Ampere Ultra. But last week or so, we also had the C4A announced by Google. And the C4A is also ARM-based, but it uses what's called the Google Axion. So slightly different, but same architecture. And so the Google Axion is a C4D. So you have a T2A or a C4D. The C4D is more standard because it looks like the options that you get with some of the other platforms. You can choose standard, you can choose high memory or a high CPU. So standard is where you'd have like 1 CPU and 4 gigs of RAM, or 2 CPUs and 8 gigs of RAM. High memory is where you would have like 1 CPU and 16 gigs of RAM. That's high memory. And high CPU is where you'd have like 1 CPU and 1 gig of RAM, or 1 CPU and 2 gigs of RAM. So you're able to actually deploy more powerful workloads. So I've added a column here with the C4A high memory, for instance, and what you'd get is 1 CPU. So it looks like what you get with the N2 standard 2 and the E2 standard 2, but this is the C4A high mem 1. You can get it with 1 CPU, 1 CPU core. It's also dedicated 8 gigs of RAM. But what you see here is it costs 75% of what the others cost. Okay, so you have 45 USD per month as opposed to 60 USD or 63 USD. So this is one of those situations where when management says, you know, how can you save on expenses, how can you save on cloud costs, you have a simple answer, right? Which is go find an ARM-based server, and you don't have to sacrifice performance, but then you can save on money. And these things can scale. So I have a max config row at the bottom, and what you see is like your E2 standard machines can have a maximum of 16 virtual CPUs and 128 gigs of RAM. And if you took the maximum, it would cost you $863 a month. Your T2A standard 2 can have a maximum of 48 virtual CPUs and 198 gigs of RAM. And that would cost you $1,400. If you compare that to your N2 standard 2, which can have 64 virtual CPUs and 512 gigs of RAM, that would cost you almost $4,000 a month, right? On just one VM, but it depends on what you're running. But you can see that you have an equivalent C4A high mem 1. The maximum config, it's actually more than 64 virtual CPUs, it's 70 something. But if you take a 64 vCPU node with 512 gigs of RAM, it's going to cost you 2,756 USD, which is still cheaper than what you'd get with an N2 standard, right? So basically, you're able to save money, save costs, not sacrifice performance by using an ARM-based VM. And you can learn more from the links on the screen. So you can learn about Google Axion and some of the architectural choices that were made in there. You can also compare various computes, various VMs from the second link on the slide. My slides will be made available. And you can learn more about ARM-based CPUs and other tech from this link on this slide, arm.com/developer-program. So please follow the links, and yeah, I'll take any questions that you have.